This video is going to be short and simple, solving exponential equations using logs. So I'm only going to do a few examples where this is going to work out, and then in the next video I'll show you how to deal with tougher examples. So for example, let's say we have 2 is equal to 0.7 to the exponent t. And I want to figure out what t is. Simply take the log of both sides. So we've got the log of 2 is equal to the log of 0.7 to the exponent t. Step 1, take the log of both sides. Step 2, you're going to apply the power law for logs. So the log of 2 is equal to t times the log of 0.7. So the power law of logs, this exponent here makes its way down to the front. So this exponent here makes its way down to the front. And then I now have a number multiplied by t equal to another number. So the log, let me just switch the color back. The log of 2 is equal to t times the log of 0.7. So t is equal to the log of 2 divided by the log of 0.7. Now that I've isolated t, I only have to determine the value of these logs, divide them, and I have my solution. So I need the log of 2 divided by the log of 0.7. So I've got the log of 2 is 0.301. And the log of 0.7 is minus 0.155. So I've got negative 0.155. So that makes t equal to 0.301 divided by 0.155. And again, that 0.155 is negative. We should expect it to be negative because we're taking the log of a number less than 1. So the exponent has to be a negative to give us a number with a magnitude less than 1. And that gives us a final answer of negative 1.94. So t is equal to negative 1.94. Final answer. Now we did a little bit of rounding to get there, so we should expect it to be off by a little bit, but you can always check these when we do them. So if I want to check to see if t is the right answer, I'll take 0.7, raise it to the exponent minus 1.94, and I should get a 2. 0.7 to the exponent negative 1.94. 0.7 to the exponent negative 1.94, and that gives me, I need to make that exponent a negative. Let me try that a second time. 0.7 to the exponent 1.94, switch to a negative, and that gives me 1.9976, which clearly rounds to 2.0 as required. To recap how that was done, when you have an exponential equation where you simply have a number on one side and an exponential on the other side, you take the log of both sides. When I took the log of both sides, I was then allowed to take that exponent and bring it down to the front. That is the power law of logs. So what I'm using to get from here to here is the power law of logs. Okay, I'm going to do another example where it's not immediately so simple first. So let's say I've got 3.2 equals 1.7 times 4 to the 2x. Can I use the power law to solve this one? The answer is yes. Now, I can't simply take the log of both sides right off the bat because you see I've got a number here that's being multiplied by my power. So I'm going to divide it out first. So in a situation like this, for the first step, let's divide out that 1.7. So I've got 3.2 over 1.7 is equal to 4 to the exponent 2x. 3.2 over 1.7. There's no reason to leave that as a fraction because I've already got decimals in it. So that's 1.88. 1.88 is 4 to the 2x. Now I can take the log of both sides. So the log of 1.88 is equal to the log of 4 to the 2x. Now I can bring that exponent down. So the log of 1.88 is equal to 2x times the log of 4. Now x is being multiplied by the log of 4. It's also being multiplied by 2. I'm going to divide both of them out. I'll do it one step at a time, but just as easily you could do this as 2 steps. So the log, you could do this all in one, one fell swoop. So the log of 1.88 divided by the log of 4 is equal to 2x. So remember, that's not giving me x, it's giving me 2x. 188 over 4. So I've got 1.88's log, remember take the log of it, divided by 4's log. And that gives me 0.455. So this is 0.455 is equal to 2x. And now finally just divide that by 2. That'll give me x. 0.455 over 2. So x is 0.455, half of that, 0.2275. 0.2275. Now let's test it. So to test this, if I take 4 and raise it to the exponent 2 times 0.2275, it should give me 1.88. So 4 to the exponent 2 times 0.2275 gives me 1.88. 1.879, which rounds to 1.88, so this is correct. Remember, you can always check these by taking that exponent you've solved for and plugging it back into the equation. Now, what made this question a little bit different is look at the beginning. I would not take the log of these two right off the bat. I'll show you what would happen if I did. So let's say I did this, I'm not going to call it wrong, it would be correct to do so. Let's say I took the log of 3.2 and made that equal to the log of 1.7 times 4 to the 2x. So let's say I did it this way, without dividing the 1.7 out first. Remember, that's how I actually did it. I divided the 1.7 out first, so that I had just a simple power here. Suppose I didn't do that. Then I'm into the law of products rule. So that would turn into the log of 3.2 is equal to the log of 1.7 plus the log of 4 to the 2x. I can still solve this. It just takes a little more work. We'd have the log of 3.2 minus the log of 1.7 equals the log of 4 to the 2x. So I'd have the log of 3.2 minus the log of 1.7 all over the log of 4 would equal 2x. Because remember, I kind of skipped a step here. I'm just showing you another way to do this. To get from here to here, you would take that 2x, bring it down to the front, and then divide out the log 4. So the log of 3.2 minus the log of 1.7 is my numerator. 3.2's log divided by 1.7's log gives me 2.2. And then I'm going to divide that by the log of 4, which gives me 3.64. And then I'm going to divide that by 2. And it gives me 1.82 for x. And when I did it the other way, yeah, I'm going to have to... A few extra steps occurred here, so perhaps there's an arithmetic error. So 3.2's log minus 1.7's log is 0.274. And we've got to divide that by the log of 4, which is 0.6. So we've got 0.274 divided by 0.604, and that gives me 0.45. 0.45 is 2x, so if I divide that by 2, it gives me 0.227. And our solution before was also 0.227. It gives us the same answer. It's just a little bit more work this way. So in the first way I did it, I divided out the 1.7 and then I took the log of both sides. So once I had just a simple power, and by a simple power I mean the base and the exponent and nothing else there. When I did it this way, I immediately took the log of both sides. However, I took the log of a product. I took the log of 1.7 times 4 to the 2x. And if you do that, you would then have to split them up to end up getting the x by itself, using the product rule for logs.